We can use subtraction to compare two numbers. Show what you subtracted. Eugene has blank more people than Springfield. If we take the Eugene's population minus the Springfield population, we will be able to fill in this blank. And we're going to do the same thing down here with world populations. So why don't you go ahead and follow my example for number 12 and then try 13 and 14 on your own. So for Eugene minus Springfield, these are the numbers I had earlier. And I'm using the rounded numbers because an approximate answer is perfectly fine here. So 178,000 minus 63,000. On your calculator, you could just type in 178 minus 63 and get 115. So it's 115,000 more people than Springfield. So implicit in this statement is that we are subtracting, even though the word is more. To find out how many more, you do a subtraction because we're talking about the difference between these two, and difference means subtracting. Okay, so try working out questions 13 and 14 on your own. And you're welcome to pause this video. So the world population in 1900 was blank more than it was in 1800. I like writing out, okay, we're going to take the 1900 population minus the 1800 population. So here are the two numbers from earlier in our work. And when I subtract these, I get 722 million. Or I could use these numbers, 1.7 billion minus 1 billion, and I get 0.7 billion. And 0.7 billion is the same thing as 722 million. If you wanted to confirm that, you could take 0.7 times 1 billion, and I can show you that. Zero 0.7 my commenting feature is not working, but I can put this into a calculator online. So one of the calculators I like is the desmos.com/scientific, or you could just do a Desmos scientific search and then go to this calculator. And if I type 0.7 times 1 billion, 9 zeros, enter, sure enough, that is the same thing as 700 million. So that's just to prove my point that 0.7 times a billion is 700 million, which is what I said right here. Okay. So same thing here, the world population in 2000 was blank more than it was in 1900. So I can subtract these two numbers. And if I do it this way, 6 billion minus 1.7 billion, I get 4.3 billion, which I can then rewrite in this format. So again, this may be confusing to you at first, but hopefully after a while you're going to get comfortable switching back and forth between these two ways of describing the same really big number. And also, you're going to find that I'm not nitpicking you very hard about the exact numbers. We're trying to be approximate with these really big numbers. Finally, we can get into comparing with division. So the world population in 2000 was blank times as big as it was in 1800. We are comparing the 2000 population to the 1800 population. So we divide. The thing that we're comparing to is what we divide by. This is our reference. And I'm writing this as a fraction where we're understanding that this fraction bar means division. So when I pop over to my answer key here, the answer is going to be about 6 times as big. And here I wrote in the actual population, and here I wrote in a slightly approximate population. It's not going to change that much depending on how accurate you are. We're always going to get into a ballpark of about 6 times as big. So from 1800 to 2000, the world population was 6 times as big. We can check by seeing if the 2000 population equals our number, which is 6 times the 1800 population. So if we take 978 million times 6, we get this number, which is not quite 6 billion, but it's close. It's close to this 6 billion number up here. And then here we're going to compare Eugene and Springfield. So the population of Eugene is 3 times as big as the population of Springfield. Or we could say about 3 times as big, because it looks like when I divided I got 2.8 something. So almost 3 times as big. Did you know that? I did not know that. I might have guessed 2 times as big. The population of Lane County is about 2 times as big as the population of Eugene. Again, we're referring back to those numbers that we had earlier in this section.